from this point on in the semester, starting with tomorrow's homework, if you have missed any homework or classwork and have not turned that in, or you missed it and didn't make it up, whatever the situation, if you have a 0 for anything between now and the end of the semester, there will be no mercy for you. What that means is that if you're a little bit below the grade, say 1 or 2% below the grade, if you have 59.9, you'll be taking this class again if you want the credits for it, because you're going to get an F. If you are sitting in a situation where you are trying to get a particular grade and you miss one of those assignments, let's say you have 89.9 and we add 10 to the 23rd more 9s. In other words, you've got to have a clean number or you don't get that grade. So 89 will not be raised to a 90, giving you an A, and at any line that you're on, that's where this mercy thing goes. Okay? Just you need to be aware of that. Also be aware and notice that up here on the whiteboard, I'm telling you that the quiz is not going to be tomorrow. It will be on Thursday. So here's what they mean by a concept map. You have to start with a balanced equation. So that's always going to be the case. So as we go down here, none of this is going to look terribly different. I like to show this as part of the concept map because it gives you a little better idea of what the balanced equation is doing. Showing a molecule for each molecule that has a coefficient of 2 or more, and only one molecule for those that have coefficients of 1. You're given and fine, just have some number of grams of hydrochloric acid going to how many grams of calcium chloride. And what that means is, remember what, this is the stuff that I called the path? That's it. This is really kind of nice because we see now for this particular problem, the concept map shows hydrochloric acid in grams being converted to hydrochloric acid in moles, being converted to calcium chloride in moles, which happens with the mole ratio in the balanced equation. See, this guy gets converted to this guy using the molar mass. That's periodic table, right? And this guy gets converted to this guy using the mole ratio in the balanced equation. Oh, I'm sorry, this guy to this guy is the mole ratio in the balanced equation. And then the calcium chloride to here, where do we get that? That's the molar mass, right? And I should say molar mass over here again. This is a great question to help you to really get the idea of what this particular chapter is all about. I have another example down here, but I don't have the actual balanced equation that goes with doing this, so it's probably best not to even look at it. But that's what they wanted in this question. Part of the do now today was to figure out what theo and actual actually mean. Theo is the calculation that we've been doing that is mimicked by this guy, okay? This is the concept map that was required for question number 19 in last night's homework. And to do this, you are going to wind up calculating what we call theo. That's the most that you can produce. So theo is your calculation. The actual has to be given. It's the product that is actually made during an experiment where you're mixing two chemicals together. Okay? For those of you who were not in class today, you'll want to make your help sheet, and this is the way it should look. Notice that you may use both sides, but you're only required to use one side. In other words, you need to fill up one side to get full credit. And this quiz is coming on Thursday. Thursday is when we have the quiz. This is how your question number 13 from last night's homework should look. And spend some time, stop the video, and make sure that what you did matches this. If not, and you don't understand why, you need to come in for help tomorrow. In this problem from last night, I always like to, because when we're doing the mole step, which is this step right here, when we do that step, if we hook up what was given, which is the sodium azide, NaN3, that you see right here, we have to convert this guy in grams to this guy, the nitrogen molecule, also in grams. Okay? So, you can't do that directly. You first have to get grams into moles, and you use the periodic table to do that. The molar mass, right? So NaN2 has to be calculated. Okay, here's the molar mass. That's where the 65 comes from, right off the periodic table. And you also are going to have to get the molar mass of nitrogen. Okay, and with nitrogen, I should have put a subscript there. Let's get that in there. Because nitrogen is N2 as a gas. And so the nitrogen is 28, and that's where this number comes from. So we're going grams of sodium azide, or sodium trinitride, however you want to name it. We've got to get the molar mass total. Okay, that's where this guy came from, the 65, which is this number. Whoops, 65. There it is. 65 from down here. Calculating molar mass. And then, once we get the moles of sodium azide, we use the balanced equation, and that little thing there tells you what we're balancing, or what we're comparing in this particular problem. So the 2 here comes from the 2 of this coefficient, and 3 comes from this coefficient. And right here, it's just adding up 2 nitrogens, which you see over here, to get how many grams of N2 in 1 mole of N2. And so the total calculation is right there. This page, you want to check your homework from last night. Okay, it's these 2 guys right here. I've got all the answers here for you, and I'm going to roll this for the video so people at home can see the answers down here, and you can stop the video as long as you want to check stuff out. And that's that part. Okay, so I think it's fun to see that reaction, because this is what we're doing right here in this particular example. So this is an example. Okay, starting the video again. This is an example of the reaction of copper with oxygen to form copper 2 oxide. And the problem comes in this form. Okay? We have a given and find. This first number is how many grams of copper, one of the reactants, we are starting with. And this would be about 10 times more copper than we did in the demonstration. So the copper is what we call the given. The actual is the other part of the given. But with the 2 of these, we can first of all calculate the theoretical yield of copper oxide, copper 2 oxide. And we do that in the same way that we've been doing all the calculations in chapter 11 and 12. Most precisely in the the third section, where we did moles to grams, grams to moles to moles to grams. So we have grams to moles to moles to grams, as you'll see in the calculation in just a minute. Okay, so let's go ahead and start with that first fraction. And Elise is not here. Alec, what's going to be our first fraction? Good. Over? Yes, good. Same old, same old. All right, nothing different here. Nothing new. This theoretical thing is what you did in last night's homework. Grams to moles to moles to grams. So you see, this is the grams part right here. And to get to the moles, how are we going to do that, Derek? What are we going to use to get us to moles? Molar mass, perfect. So for copper, copper is on the periodic chart in position 29. So what's the molar mass we're going to use? And should it be top or bottom? You're going to put the mass on top? Why do you put it on the bottom? Shh. Gary? Yeah, if we divide, what do we accomplish? Anyone? Really? Got to cancel, right? So we put the 63.5 from the periodic table on the bottom, and that gets grams to moles. Okay? When we cancel the grams here with the grams here, see, this is a ratio. And so for every 63.5 grams of copper, we have a mole of copper. Now that's the AVO number of atoms, but the important thing is that it is a mole, and we can work with moles to change one substance to another, which is the magic of this particular type of calculation. Ashley, what do we have in our next fraction on the bottom? Jocelyn. What do you have? What's going to be on the bottom of the next fraction? Copper, moles or grams. Good. How many? For that, you look up here, right? What? 2. Good. And what's going to be on the top? It's 2 to 2, which we could simplify to, or reduce is the way you say it. So we reduce that to a 1-to-1 ratio, which is why this 2 to 2 becomes a 1-to-1. You could do either way. It wouldn't matter. You'd get the same numbers at the end. Okay, and the last one is going to Judith. Okay, Judith, what do you have? How are we going to get this moles of copper oxide, copper 2 oxide? How are we going to get that into grams? Molar mass. Okay, so there it is. What's our number on the bottom? You got it. 142 grams is on the top, though. So you can't put your grams on the bottom. You can't put grams on the bottom because we're trying to cancel the moles. So you got your 1 mole. See, 1 mole is equal to 142.8 according to the periodic table. Okay? And that gets you your answer. This is your model for all of your homework, for your 2 homework problems. And, we didn't do the percent yield, so let's do that right now. This is the easy part. See, once you do this calculation, things get very easy because we simply take this number here, put it down on the bottom for the percent yield, and over here we have the grams that were given us here as the actual. So this is how much got produced, and this is how much we started with. Okay? So we're comparing grams to grams. And this is how it works all the time. This is something that we did in the do now. The percent yield is actual over Theo times 100. So when you think percent yield, always think that Theo's coming from the calculation and that actual is something that they will give us as part of the experiment. And that's how it works. What we're doing in class is we're doing a given and find. This is number 27 on page 372. And we are now working in groups of 4 to go ahead and figure out what the calculation is going to look like. So I'm just disbanding the class, so to speak, putting you into groups of 4, and we're going to run this guy and see if we can get the correct numbers. What I'm doing for everyone in class is to give the actual percent yield. Okay, the percent yield is the actual over what you calculate for the Theo. Okay, so this will tell you if you get the right answer. If you don't get this answer, you need to come with questions tomorrow to figure out why you missed. Okay, it might be a molar mass problem, or you didn't get the right mole ratio. Any of that could be the problem. But this is the balanced equation that we're working with in problem number 27 on page 372. Hope this video has helped.